Boys, today I'm going to start a new topic, Chapter 6 Circle, which is there for your second unit test. Now, this is the theorem which I have written. A perpendicular drawn from the center of a circle on its chord bisects the chord. Now, a circle meaning one circle, and there is a center. So, O is the center. And there is a chord. So, AB is the chord. Now, what we have to prove here in this case is a perpendicular drawn from the center of the circle. So, this is a perpendicular OP is perpendicular drawn from the center on its chord. So, it is this OP is on the chord AB. Then we have to prove that OP bisects the chord AB into two equal parts. So we have to prove PA is equal to PB. So always remember that when OP is perpendicular to AB, then P is the midpoint of AB. I hope you now know it. So again I am reminding you, if OP is perpendicular to AB, then PA is equal to PB. So this theorem you must know. So the word is given, if it is perpendicular to the chord, then this chord is divided into two equal parts. So now over here listen. You have to write down the given. In the given, you will write down first statement is O is the point O, or O is the center of the circle. Second point is AB, or you can write a segment AB. AB is the chord of the circle. Third, you have to tell that OP is perpendicular, that is segment OP, perpendicular to chord AB, or OP perpendicular to AB. This is also right, boys. So you must remember there are 3 points for the given. Now, what we have to prove is, we have to prove that PA is equal to PB, or segment PA congruent to segment PB. Anyone you can write it. This is what we have to prove. Next comes a construction after proof. In construction, we have to say join OA and OB, or draw joint segment OA and segment OB. So this is coming in the construction. Now comes the proof. When you write down the proof, we require two triangles. So we are taking the triangle OPA. So you have to use a word. When you are writing proof, you have to write down in triangle OPA and. So when you write in, you have to write down the word and in the middle. And triangle OPB. And whenever you take two triangles, there are 3 statements along with 3 reasons. So over here, now what I'm going to do here is, you know that OA is the radius, OB is also radius. So their length are equal. So OA is equal to OB, that is the radii of the circle. That's the first point. Second, OP is a common side for both the triangle. Third, each of this angle is how much? 90 degree. So you see over here in these two figures that both the triangles are congruent by hypotenuse. This is called hypotenuse. Why? Because it is facing to 90 degree. Hypotenuse side test. So now you will write it. So once both the triangles are congruent, naturally segment PA is congruent to segment PP, and that is what we have to prove. So now we are writing two triangles with three statements. First one, segment OA congruent to segment OB. Radii of same circle. Next one, segment OP congruent to segment OP, common side. And third, angle OPA is congruent to angle OPB, each 90 degree. So always you require three statements with three reasons. Therefore, now you write down the word therefore. You will not write again in. Therefore, triangle OPA, and you will use this symbol, that is congruent. Now you have to write down congruent. Congruent to triangle OPB by which test? Hypotenuse side test or hypotenuse side theorem. And then you write down segment PA is congruent to segment PB by corresponding sides of congruent triangle. This you can write down with the initials. There is no need to write down the full form for this case. So this is what we have proved over here. So now, or when you remove the segment, then you can write down PA is equal to PB. When you put equal sign, then no need of writing segment. So this is over. So I want you to practice this theorem minimum 3 times. So now you must remember that a perpendicular drawn from the center of the circle on its chord bisects the chord. So you must always remember, I'll ask you also, if OP is perpendicular to AP, meaning P is the midpoint. When P is the midpoint, PA is equal to PB.